thing that we're going to do here today is we're going to go through the notes for the new section 5.4. It's just a couple slides here, so it should be relatively quick. You should still have some time to work. And so the two concepts, or the concepts that's going to be covered in this section, has to do with solving information about isosceles triangles and information about equilateral triangles. And so let's talk about isosceles triangles first. First of all, the anatomy of it. An isosceles triangle has two or more equal sides. The two equal sides are called legs. Okay, and then the side that connects the two equal sides is the base. Okay, so just terminology-wise, that's what it's referring to. And then the two base angles here are opposite the legs. Okay, so the base angles are the angles opposite the legs. So terminology-wise, that's what you can expect when you hear me say those phrases. Okay? So the first relationship is the base angles theorem, and that is when you're dealing with a triangle, if you have legs that are equal, then the angles opposite those equal legs are also equal. Okay? So this is in a given triangle. Angles opposite congruent sides are congruent. Okay, and so what this is saying is if AB is congruent to AC, then the relationship is angle B is congruent to angle C. And then there's a converse of this. Again, if you go back to early chapters, the converse just switches the hypothesis and conclusion. And so what this is saying that if you're dealing with a triangle, if you have sides that are equal, then the angles opposite those sides are going to be congruent. And so this isn't written in a conditional statement the same way a normal converse would be. But what's happening here is that the conclusion that the sides are congruent is now the condition you're starting with. And the result is that the angles opposite those will be congruent as well. So this is saying that if you have congruent angles, so if angle B and angle C are congruent, then the conclusion you can draw is that sides AB and sides AC would be congruent to each other also. All right, so what I want you to do is try a couple things here. Again, the questions that we have for these are going to involve some of the conditions and properties that we looked at in 5.1, 5.2, 5.3, okay? Or 5.1 and 5.2. So I want you to see just this top question. Can you find what the base angle and vertex angle is if you know the given information? And so again, try this on your own before I go through it. It's based on these definitions as well as the concepts of triangle sum that we've already discussed. Now, most of the time when you sketch an isosceles triangle, they tend to look like this. It doesn't mean that it can't be written or can't be drawn like an ice cream cone or can't be drawn on the side. Okay, but this is kind of the general way. Base angle doesn't mean it's the bottom angle. Okay, base angle means that it's opposite the congruent sides. So here, if you say that this isosceles triangle has a base angle of 14 degrees. Well, if this angle is 14 degrees, what do we know about the base angles here? If sides are equal, then the angles opposite them are also equal. So that means that the other base angle will also be 14 degrees. And to find the total vertex angle, this remaining angle up here, you would use triangle sum. And again, it's just a calculation, right? The total sum, 180, is equal to or this angle right here is equal to 180 minus the two given angles. And so if you calculate 180 minus 14 and minus another 14, you get your answer of 152. Okay, so these would be your solutions for that problem. So obviously the sketch is not to scale, right? It would be an obtuse angle, but as long as you sketch it and label it, you should be okay. All right, so try the second question here. Similar idea. You have this isosceles triangle, but here you're trying to find what is the base angle, what is each base angle, if you know what the vertex angle is. So see if you can find that, please. All right, so here you have a couple different options to do this. One is if you're just going to add up the parts, right? All three of these angles add up to 180. This is triangle sum. And you can calculate from there. Subtract 38 from both sides. And you'll get 2x is equal to 142. Divide by 2. 2 goes into 14, 7 into 2 once. So you would get each x to be 71. Now, there's another way that you could, again, just directly plug in the calculation. And that is, if you know that the total sum is 180 minus this 38, and then the remaining, whatever remains after that, is cut in half. And each of those angles represents those. So this would be the direct calculation you can enter to get the same, the value by entering the calculation. All right, try this last question here. Last question is the same idea using the properties of an isosceles triangle and the base angles that are equal, but now you have expressions that you'll use for each of the angles. So see if you can solve for the angle C. Take a look at this problem right here. Okay, the first thing is to determine in this isosceles triangle, your equal base angles are B and C. So that means that this expression, or this angle here, can also be expressed as a 5x plus 13. Right? So what you know is that the sum of all these angles, x plus you have two of these 5x plus 13s, they have to add up to 180. And so this is triangle sum. You can write those expressions individually as well, right? 5x plus 13 plus another 5x plus 13. However you set those up, I'm going to go ahead and distribute the 2 here. I get 10x plus 26. And now I'm going to solve for my x value. So I have a total of 11x. If I subtract 26 from both sides, I get 154. Divide by 11 to calculate my x value, and I wind up with 14. Now, here's where you need to be really careful, right? Because when you're solving for problems that involve calculating with variables, you're going to be asked one of two things generally. You're going to be asked solve for x, or you're going to be asked solve for a given measure where you have to substitute the value of x in to evaluate it. And notice here you're asked for angle C. Well, angle C is going to be 5 times x plus 13, right? So it's not a bad idea to get in the habit of, if you are entering an answer that's an expression, put in the expression, leave a space, leave that like gap to fill in your value of x. Once you find that x, you can plug it in here. If you do it this way, the display will give you the calculated value. So the answer is 83. So the angle C is 83. Again, if it had asked you specifically for angle A, it would be 14. If it asked you to solve for x, that would also be 14. So just make sure that you're entering your answers based specifically on what question is being asked. And it can vary. Sometimes it's find x, sometimes it's find the expression. All right, the last problem, we'll demonstrate that again, but before we get to it, let's talk about the properties of equilateral triangle. Okay, so first, an equilateral triangle is defined in two ways. Okay, so first it has all three congruent sides. Okay, and it also can be identified that exact same triangle that has all three equal sides also has all three equal angles. And because the triangle sum, if you think of these as x, x, and x, 3x adds up to a total of sum of angles of 180. You get that the measure of each of those angles is 60 degrees. All right, so based on that, I want you first to try this question to the left. And can you find what x would be given this equilateral triangle? Here, the first problem is labeling your angle measures, right? So there's a couple different ways you can approach this problem. How many of you set these two expressions equal to each other, solve for x? Okay, so that's one way. How many of you did something different? And what'd you do?
I added them together and then I made them equal to 120.
Okay, so you could make all of them equal. There's one other thing that's even easier that you can do to solve this.
I just did 15x plus 15x plus 20.
Okay, so same thing. I think so you guys, you all talked about process that can work, right? But here's something that's even easier. What do you know each angle measure is equal to? 60, right? So all you would have to do is take one of these two expressions. Which one do you think would be easier to set equal to 60? So I'm going to take that measure, set it equal to 60, and solve. So if I solve this, I subtract 20 from both sides, divide by 5, I get x is equal to 8. Now, that's not the only way, right? And you could have also done this the ways that you guys talked about, right? So 3x plus 36 is equal to 5x plus 20. We do know that those are equal angles. So you could solve it that way if that was the case. You could subtract 3x from both sides, subtract 20 from both sides, and then solve by dividing by 2. Okay, and then again, what some of you said was what you assign C to be one of these expressions, right? It doesn't matter which one. That one, again, probably is a little bit easier. And if you add all of those three angles together, set them equal to 180, you can solve it that way as well. But again, it's up to you. Whatever's comfortable, whatever you see, there's a number of different paths that lead you to the same solution. All right, try this next question. The next question deals with sides rather than angles. But see if you can find what CA is equal to in that problem. So when you're looking at this problem, equilateral triangle means all three of these sides are the same. So when we look at CA, CA can be expressed as either 14x or 11x plus 30. Since we're finding CA, again, I'm just going to remind myself that I'm not just solving for x here. I'm going to find a measure, and I'm just going to use the one that, whichever of these makes the most sense, or that seems to be the easiest to calculate. So 14x is fewer entries on or when I type it in. So all I need to do, though, is solve for x, and I can do that by setting these two sides equal to each other, which means that the expression 14x and the expression 11x plus 30 are equivalent. Subtract 11x from both sides and solve. X is equal to 10, plug that in, and I get my answer to be 140. All right, so that is